Hello, students. Good morning. And this is Smart Kids Learning Center, the tutoring class. And our contact number 647-778-8725 for online classes. So our school majoring tutoring high school maths for advanced function calculus, also for English, as well as teach all the school subjects homework and help students to complete their homework and get good grade. And all the new students will receive the first free online class. Welcome you to join. And today I'm going to teach you for the high school textbook. For a Ryerson, advanced function grade 12. Hope your school using the same textbook. So even not the same textbook, all the grade 12 advanced function textbook, they have the same concepts. You can learn the knowledge and apply for the exercise. Now, let's open the book. I'm going to teach you today the concept for chapter 1 in unit 1.3 on page 33. Let's open the book. So now we are in the chapter 1. So what is about? Look at the textbook. It's analyzing the graph of a polynomial function. So there's two graphs. So what is asking? The first one, answer the leading possible degree and the sign of the leading coefficient. And number 2, the x-intercept and the factors of the function. Number 3, the intervals where the function is positive and the interval where it's negative. So look at the graph here. So you see this is the parenthetic one. It will be y equal x exponent 3. So count the curve 1, 2, n plus 1. So answer the first question. The least possible degree is a 3. The sign of opening, so if it's a parenthetic one, will be drawn from quadrant 3 to quadrant 1. So I usually draw from here, like 1 and then 3. So this one is opposite. So therefore, the leading is negative. So number 2, x-intercept and the factor of the function. So x-intercept we get -5, 0, and 3. So the factor will be x plus 5 and x minus 3. So the one x minus 0, so you just can combine it together. So and 3, the intervals where the function is positive and where the function is negative. So you can see from the negative infinitive to a -5, the function is positive. All the y are positive. And from -5 to 0, all the y value are negative, the function negative. From 0 to 3, so above y, above the axis, y positive is a positive function. Now from positive 3 to a positive infinitive, the graph vivata is -y. So the function is negative. And that's how to do analysis the graph. I'm going to do analysis for the B, the second graph. Number 1, the least possible and the sign of the opening. So when the end behavior are the same, they open up. It's an even degree. So you can count the curve line 1, 2, 3. 3 is n plus 1. So therefore, it's a 4 degree. The sign of open up is positive leading coefficient. Number 2, x-intercept. So x-intercept -2, 1, and 3. So the factor will be x at 2 x minus 1, x minus 3. You see the minus 3, this curved line is wider intercept here. So therefore, it's called order 2 will be x minus 3 exponent 2. Now, the intervals where the function is positive. So from negative infinity to a negative 2, positive 1. From negative 2 to a positive 1 is negative 5, negative. From 1 to a 3, positive 5, positive. And from 3 to a positive infinity is all positive. That's how to do the analysis. And now I'm going to show you how to put it in writing. Now we're going to put the verbal analysis into a writing. So I'm going to plot the graph first. So how to plot it? So you're going to write all the x-intercept. So what is an x-intercept? So x equal negative 5 and 0 and a positive 3. So what is the y-intercept? So I'm going to write here, y-intercept is at the origin. So that's all we need to do. And the leading coefficient is negative. So I put negative 5 here, 0 here, and 3 here. So we're going to join from the top here. And going down and move it to the y-intercept and up. And then going down. So put arrows. Now, and then we're going to write the analysis. So for I, number 1. So you're going to write x-intercepts. So we already wrote it. So and then you're going to write, it's going to be, the graph is from quadrant, so Q2 to 4. So the leading coefficient 10 to 4. So pay attention. Now for the first part, so you're going to write the x-intercepts into a factor. So like x plus 5 and x plus 0 and x minus 3. So we are going to do the interval analysis. Now you can see from negative infinity to a positive. So the first negative infinity to a negative y, negative 5. The function is increase. So I write increase function. So the next one is going to be from negative 5 to 0. So that's, we put x. The function is negative 5, decrease. Now, and then from 0 to 3, the interval. Positive 5, increase again. So, and then from x to 3 to positive infinity, you see it's revert down, negative 5 is decrease. Or you can use a sign, positive, negative, positive, and negative. Now, and that's how to write it. So, and you can write, these are the intervals. Now we finish the first, and then we're going to do the B. Now B is an even function. So we're going to plot it first. So the x-intercept, we write x-intercept here. So for number 1. So x equal -2, 1, and 3. So 3 is order 2. Order 2 means this factor will be exponent 2. So we mark the -2 and 1 and 3. So what is the y-intercept? So we're going to write y-intercept. As we look at the graph, it's going to be -20. So we put it -20 here. Now we're going to plot the graph. So from the third quadrant and river to the y-intercept, and then move up to a 1, and then to a 3. So this is the order 3. So we make it to a y-touch. And that's the graph. From Q2 to Q1. So we're going to write Q2 to Q1. So the leading coefficient, so I put short form, is positive. So, and the end behavior both open up. So how about number 2? We're going to write the factors. By x plus 2, x minus 1, and x minus 3 exponent 2. So I'm going to put up here and you can see the vision better. Now we're going to write the intervals. So as you see the graph, so from -∞ to a -2, so the first interval. So it's I write in a short form, express it, understand the concept. So x from -∞, so to a -2. So you see the line is positive y. So therefore, moving up, positive. So the next one, x. So from -2 to a 1. So the y is negative, open down. So we put negative. Now x from 1 to 3. Excuse me. So from 1 to 3, you see the line here is above the x. Y is positive. So open up, positive. So, and then from 3 to positive infinity. Y all positive. So open up. That's how we do the analysis for the example 2. Now, I hope you understand the concept. Analysis the graph and write into analysis form. Now we're going to move on for the second example. Now, example 2 in the book, analysis equation to sketch the graph of the polynomial function. Number 1, y equal x minus 1 times x plus 2 times x plus 1. So to do analysis, what are you going to do? You need to draw a chart like degree, leading degree, and behavior, the x-intercept and y-intercept. So for this equation, you know the degree. You count by the factor 1, 2, 3, degree 3, x equal exponent 2 is positive A, leading positive, and end behavior is going to be from quadrant 3 to a 1. So, and then x-intercept, x equal 1, -2, and -3. Y-intercept, you're going to plug in x equals 0, will be -1 times 2 times 3. You got -6. And that's how you do the chart analysis. and also plot the graph. I'm going to show you in a rectangle. Now the function is y equal x minus 1 and x plus 2, x plus 3. Now we count the leader. 1, 2, 3. So leading degree is 3. So you can write y equal x exponent 3, the parental function. Now the leading coefficient is positive. So we write positive. Now the end behavior. So its positive is going to be rise from the quadrant 3 to a 1. So you can write Q3 to Q1. Now the x-intercepts. So we're going to write x equal 1, negative 2, negative 3. Now the y-intercept, when x equals 0, it will be 2 times 3 times negative 1. We get negative 6. That's how you do it easily. Now we plot the graph now. So negative 3 and negative 2. So we get the negative 2 here. So, and then for positive 1, then we get a positive 1 here. Y-intercept negative 6. We put negative 6. Now we're going to plot it negative leading or positive leading, positive. We have to conform. Now we're going to write Viva from negative 3 and up and down, and Viva to the y-intercept and up. So we have 3 curve y. Now you can know if you want to analyze the graph from negative infinity to negative 3, negative function. From negative 3 to negative 2, positive function. From negative 2 to a positive 1 is negative function. And from positive 1 to positive infinity is a positive function. And that's for the example 2 for A. And we are going to do the next one. For example 2, in the B, y equal negative 2 times 2x minus 1. Exponent 2 means order 2 times x at 2. Now we're going to count the degree. So 2 and 1, we get degree 3. So the y equal x exponent 3. So, and then the leading is negative 2. Then we put the negative here. So leading is negative. So how about end behavior? So if negative is going to be from the second to, how about x-intercept? We're going to write this x-intercept. So we're going to have an x equal positive 1 over 2 and negative 2. So y-intercept, when x equals 0, that will be a 1 positive 1. Positive 1 times 2, we get 2. 2 times 2, we get a negative 4. Now we're going to plot it. So a negative leading from 2 to 4. So we're going to Viva to the x-intercept. So in the end, to a y-intercept. And then to 1 over 2. The graph will be like that. X-intercept negative 2 and 1 over 2 and y-intercept. So you can see as x from negative infinity to negative 2 is a positive function. And from negative 2 to a positive 1 over 2 is a negative function, y or negative. And also from 1 over 2 to a positive infinity, also negative y, negative function. And that's for the example 2. Function is y equal negative a, and then times 2x plus 1 exponent 3 times x minus 3. Now, how many degrees we count? 3 here and 1 here we get a degree 4. So we write 4 here. So we write the parental function, x exponent 4. So the y here, the a is negative leading. So will be a negative x exponent 4. Now the end behavior. So if it's a negative leading, it's going to be open down. So it's going to be from, when it's open down, it's going to be from the third quadrant to a fourth. So we're going to write Q3 to Q4. So, and then the x-intercept. So x equal -1/2 and a 3. So how about a y-intercept? So when x equals 0, will be a 1 times -3 and times -1. We're going to have a +3. Now we're going to plot the graph. So we plot the x-intercept, -1/2 and 3. The y-intercept is a 3. So we're going to plot it from the third quadrant. So we write the line like that. And that's the order 3. So therefore, this part, we have a y-touch. So, and then rise to the y-intercept. So, and then going down, viva to the x-intercept. That's the graph from the quadrant 3rd to a 4. So the intercept, 2 intercepts and y-intercept. So if you do analysis, the end behavior will be from -∞ to a -1/2. The y all negative, function negative. So from -1/2 to a 3, y all positive, the function positive. From 3 to a positive infinitive, y negative. It's a negative function. And that's how to understand and do analysis for the polynomial function. For the unit 1.3, example 1 and 2. And we are going to do the next. And these 2 examples and the concepts are in the Ryerson Advanced Function Gr.12 book. And you can refer the concept and the knowledge to do exercise. If you have questions, feel free to text me this number and I will answer your question and write your solution. And this is our school online class and the grade 12 advanced function calculus, and as well as all the school homework I will teach students to do. And the first class is free. Feel free to contact us. Thank you. And I'm going to see you in the next video. Please subscribe. Thank you. Bye.